Good morning, good afternoon, good evening, Michael, Matthew, Chase, whatever day or time of the day it is you're watching this video. Let's get going right away so we can get this over with and let you continue on with your day. If you have not ran the copies of your notes, please pause the video and do that now. You will want to have these in front of you. Chase, Matthew, please listen carefully. When you walk into class next Monday, I'm going to remind you of this every day in the videos. When you walk into class next Monday, you will owe me a quiz and a test. You're not going to have time to ask questions on those. Well, you might have time, but you have to be able to turn them in Monday. If you do not turn in your test and quiz, you will be losing points on those. So Matthew, you owe me an old test. Chase, you owe me an old test. Chase, you owe me a couple. I don't care which one you give me. Then both of you guys owe me the quiz I gave you in class on last Thursday. So you need to be calling me, emailing me, contacting me, visiting me, doing something if you have questions so those are answered before you get started. Okay, grab your before you come to class on Monday and turn them in. Okay, let's go ahead and take a look at our notes today. First of all, I'm not going to review because you just took a quiz. Hopefully you will be taking a quiz this week, and that would be a nice review for you. If you look at the top of your sheet, I'm going to scribble right here in front of you. But at the top of your handout, it should say this: solving exponential equations. All right. Now, of course, all this is in front of you. I'm not trying to worry about being neat. It's all right there in front of you, lesson 8.6, and the date today is the 22nd. Now, if you will please look beneath that, I have given you two examples of two exponential equations. Here's the first one. If you will quickly look in your notes, you will see this right here. Let's see, 4x minus 2 plus 9. And there's another equation over here, 5 to the 3x plus 2 power equals 25 to the 4x. Now, please look at these two equations in your notes. Find these two equations in your notes, and I want to talk to you about these. Both of these are called exponential equations because, look, your unknown is up in the exponent. Do you see that? There's your x. It's up in the exponent. See your unknown? It's up in the exponent. See your unknown? It's up in the exponent. Thus, we call these exponential equations. Now, do you see how these are? Let me draw a line here. Do you see how these are two different types? Do you see the difference? Look, one of these equations has one exponent that's unknown. There it is. When you look at this equation over here, students, notice we have an exponent here with an unknown and an exponent here. Notice in your notes, I've given you two different sets of steps. So when you start solving these today later on in your homework, you had better learn to ask yourself this one question. Are you ready? Ask yourself, is this the type of exponential equation that has an exponent with an unknown, or is this the type of equation that has two exponents and each one has an x? Because they're done differently, students, and if you don't see that, then you're going to be confused. So do you see the difference? One exponential equation has one exponent with an unknown. The other type of equation has two exponents with unknowns. And so they're done differently. I'm not going to write the steps down for you. They're in your notes, okay? But if you'll please look at your notes very quickly. For this type of equation here in which you have one exponent with an unknown, the steps are isolate the base and the exponent. Step 2, take the log of both sides. And I will explain that to you later. Number 3, simplify both sides. And number 4, isolate the x. And so there's the steps for this type of equation. Do you see those in your notes? I will explain those to you in just a second, okay? Now let's come over here to this type of exponential equation. This is a type of equation that has two exponents that have unknowns. 1, 2. And the steps for this are, they're in your notes. You can follow along as I read it out loud. Write both sides with the same base. Step 2, cancel the bases and set the exponents equal to each other. Now, Mike, Chase, Matthew, if you will look at the first three problems that we're about ready to work, do you notice how these three equations match this type of equation right here? Do you see that? Look at the first three equations that we're going to solve in your notes. Notice how all three of those equations have two exponents, and each one has an unknown. They match this type of equation over here. So we're going to use these steps right here in your notes, these steps right here for the first three problems. So here we go. Please take some really good notes. Let's learn how to solve exponential equations. Here's the first one. Take some really good notes, please. 4 to the 3x power equals 8 to the x plus 1 power. Now, this is the type of equation that has two exponents, 1, 2, with an unknown. So we use the steps that you see up above in your notes that say, first of all, write both sides with the same base. Well, here we go. I have a 4 and an 8. My base is a 4. My base is an 8. They are not the same. So I'm going to have to rewrite this equation so that they have the same base. Well, everybody knows that 2 squared equals 4, right? Everybody knows that. So where the 4 is, I really could just substitute 2 squared and then bring down your 3x. And really everybody should know that 8 is the same thing as 2 to the third power. 2 times 2 times 2. So where the 8 is, I could substitute 2 to the third power and then bring down your x plus 1. Do you see what I've done there? Just a simple substitution. Now, Mr. Erhart, how did you know to do that? Well, you're going to have to practice these guys. I mean, you have to learn to look at the bases. It's kind of like a puzzle. It's fun. You got to look at the bases and say to yourself, how can I change these bases so that they're the same? Now, let's go ahead and simplify. So I really have 2 to the 6x. I don't think I included that in your steps, but to me it's pretty much common sense that we're going to simplify. Okay, do you guys see where the 6x came from? 2 times 3x, 6x. Do you see where the 3x plus 3 came from? 3 times x plus 1, so 3 times x, and 3 times 1, 3x plus 3. And now look at step number 2, please. Look at step number 2. Cancel the bases and set the exponents equal to each other. So I cancel the base, and I have 6x equals 3x plus 3. Well, that's pretty easy now. Bring the 3x over and make it a negative 3x. And that leaves me with 3x equals 3. Divide both sides by 3. Divide by 3. Divide by 3. And x equals 1. There we go. Not too bad. Okay? All right, let's try another one. If you need to read, now I go fast on the videos because you cannot speed me up, but you can always slow me down by rewinding or pausing. So that's why I go pretty fast, and then you can slow me down if you need to. This one's actually easier than the other one, so we're getting a little easier here on the second one. All right, this is the second problem in your notes. Well, I think right away you should see that we have the type of equation here that has two exponents, 1, 2, that have an unknown here, and an unknown here. So we're going to use the set of steps that match this equation. Step 1 says write both sides with the same base. Well, I'm not going to worry about the 3. The 3 can stay a 3. But the 9? Well, we all know that 3 squared equals 9. 3 times 3. So where the 9 is, I'm going to substitute 3 squared and then bring down my 2x. Do you see that? Substitute 3 squared for the 9. And now I would have 3 to the 4x. Do you see where the 4x came from? 2 times 2x equals 3 to the x minus 6. Well, now use the last step. Cross off your bases and set the exponents equal. So 4x equals x minus 6. Subtract, that will bring the x over to this side and make it a negative x. That would leave you with 3x equals negative 6. Divide both sides by 3, and x equals negative 2. Cool. One more, then we'll go on to the other type of exponential equation. All right? And that's all we're doing today. Pretty quick lesson. All right? All right, let's take a look here. All right, we're on number 3 in your notes. Number 3. We have 9 to the 2x power equals, excuse me, sorry, 27 to the 3x minus 1. All right, well, you should notice right away we have the type of equation that has two exponents with unknowns. Here's one and here's the other. So step 1 says to write both sides with the same base. So for 9, I'm going to write 3 squared, because 3 times 3 is 9. Bring down your 2x. And then for 27, think about it. 3 times 3 times 3 is 27. So 3 to the third power is 27. Bring down your 3x minus 1. Now, when you have a power raised to a power, you multiply those. So I would have 3 to the 4x. And over here I have a power raised to a power. So it's 3 times 3x. It's also 3 times negative 1. So I would have 9x minus 3. 9x minus 3. Well, step 2 says to cancel your bases and set the exponents equal to each other. So 4x equals 9x minus 3. Let's bring the 9x over and make it a negative 9x. So now I have negative 5x equals negative 3. Not too bad. And now divide both sides by negative 5. So we divide by a negative 5 here. We divide by a negative 5 here. And we are left with x equals, well, a negative divided by a negative is a positive. And you're welcome to put 0.6 if you want a decimal answer, or you can leave it 3/5. That's totally up to you. Now, students, please listen to me carefully. Notice the last 3 problems. Here they are. Look up here. This one, and this one. The first 3 in your notes. Let's go way back to the very beginning of your notes. Those equations that we just did matched this type right here. Do y'all see that okay? We had 2 exponents with unknowns. Now the next 3 problems, let me go back up. The next 3 problems are going to match these right here in your notes. Okay, does everybody see that? Way up at the top of the first piece of paper in your notes. The equations we're going to solve now will match this type of equation right here. So here we go. Let's take a look at the next equation. All right, here it is in your notes. You can see it already. It's right in front of you. 10 to the 2x minus 3 plus 4 equals 21. Now, please listen carefully. Let's take a look at these steps. Step 1 says isolate the base and the exponent. Step 1 says isolate the base and the exponent. Do you see this is one of the equations that has one exponent with an unknown? So we are going to use the steps in our notes, sorry about that, that match these types of steps. So step 1 is isolate the base and the exponent. So would you please watch carefully what I'm going to do? I'm going to circle the base and the exponent. There it is. We want to isolate that whole thing. So if I want to isolate that whole thing, it looks like to me I'm going to have to subtract 4 from both sides. So subtract 4, and I'm left with 10 to the 2x minus 3 equals 17. Do you see that okay? Now the base and its exponent are isolated. They're all by themselves on one side. Let's go on to step 2. Step 2 says take the log of both sides. Now students, I really need you to listen to me carefully, please, okay? Watch carefully. If I'm going to take the log of both sides, I want you to go ahead and write the words log like this. If you're going to take the log of both sides, what base do you use? Did you hear that? What base are you going to use? Well, here's what base you use. Whatever the base is of your exponent, in this case it happens to be a 10. It won't always be a 10, but in this case it happens to be a 10. Whatever this number is right here, that's the base you want to use in your logarithm. So go ahead and put log base 10, log base 10. All right? Let's go over that again. Step 2 says you want to take the logarithm of both sides. Now you'll see why in a second. What base do you use? Whatever this number here is. Now bring down this whole side. So you're taking log base 10 of this whole side. And you're taking log base 10 of this whole side. So bring down your 17. There we go. Now Mr. Erhart, why would you do that? I'm glad you asked. I'm going to tell you why. Because we learned a property a long time ago that when this base right here matches this base right here, everything cancels out and you're left with just the exponent. So now you're seeing why I wanted you to use the base here that matches this base here. Well, Mr. Erhart, can you do that? Yeah, you can do that. As long as if you take log 10 of one side, you do it to the other side, sure you can. So if you'll look at your notes, please, step 2 says take the log of both sides, and we have done that. Now step 3 says simplify both sides. Well, I really can't simplify this side over here, log base 10 of 17, but I can simplify this side. Whenever the log base matches the argument base, the whole thing equals just the exponent. So this whole left side becomes 2x minus 3. All right. Now we're going to practice 2 more of these, then we'll start your homework. You can see now the video is going to be pretty short, probably 20, 25 minutes, and then you can work on your homework. So it's not that long. But let's look at your steps. Step 1, step 2, these steps are very important. Step 1, isolate the base and the exponent. We did that. Step 2, take the log of both sides. We did that. Step 3, simplify both sides. Well, we simplified the one side that we could. Would you please look at your notes? Mike, Matthew, Chase. Step 4 says isolate the x. That means get x all by itself. So if I'm going to get x by itself, I've got to add 3 to both sides. Please don't make that 17 to 20. Please do not make that 17 to 20. You are taking the logarithm of 17 and then adding 3 to it. You do not put these two numbers together. Do not do that. You are taking the logarithm base 10 of 17, and then whatever you get out, you're adding 3. Please do not add those two numbers. This log and this 17 all go together. Please don't do that. All right? I don't know why I keep doing that. All right, let's continue on. Now let me quickly cut and paste this, and then we'll move on. All right, so let's continue the problem. New page here, paste. All right, here we go. Now, we must now, to isolate the x, we're going to divide both sides by 2. So divide by 2, x equals log base 10 of 17 plus 3 all over 2. Now that's not sufficient for me, okay? You can type this into your calculator. Remember, your calculator does log base 10s automatically. If you'll look to the left side of your calculator, I think it's the 4th button from the bottom. If you'll see this button right here, it says log. Remember, when you hit that button, it automatically does base 10. So let's go ahead and type this log base 10 of 17 into our calculator. Now, if you type log of 17 into your calculator, you should get this decimal out. If you're not, you're making a mistake somewhere. So this log base 10 of 17 should be, I'm rounding, it should be 1.2304 plus 3 all over 2. And now you're seeing way back here, please watch, why I told you when you added 3 to both sides. I'm not sure why I didn't put plus 3 back here, but anyways, when you add 3 to both sides, you don't add the 17 to 3. Do not do that, okay? All right. Now, log base 10 of 17 is 1.2304. Then go ahead and add 3 to that, and then divide by 2. So plus 3, and then divided by 2. And your answer should be something like this. You might be off a couple hundredths because you rounded in a different place, but you should get 2.1152 approximately. So there's your answer. Let's do 2 more of these, okay? We need to practice these, so let's do a couple more, and then I'm done. That's it. We're done, and you're welcome to start your homework, okay? Which will be, I think, about 9 problems. I think that's right. Let's see, 35, 8, yeah, 9 problems. Okay, if you'll look at the next problem in your notes, it looks like this. 12 to the 3x minus 4 equals 0.1. Now, ask yourself this question. Is this the type of exponential equation that has 2 exponents with unknowns or 1 exponent with unknown? Well, it has 1 exponent with 1 unknown. So we use these steps. Step 1, isolate the base and the exponent. Well, this is the base and this is the exponent. And students, they're totally isolated. Step 1 is done for you. They're totally isolated, okay? All right, so step 2 says take the logarithm of both sides. So I'm going to write the word log, then leave a little space, put an equal sign, then write the word log. Now remember, what base do I know to use? Well, look up here. What is this number right here, the base of your exponent? In the last problem, it was a 10. In this problem, it's a 12. So we're going to put log base 12, log base 12. Do you see how to do that? And then bring down this entire side right there, so it looks like this. 12 to the 3x minus 4. And then bring down this entire side right here, so it looks like this, log base 12 of 0.1. Okay, now step 3 says simplify both sides. Well, I really can't simplify the right side. But I can simplify this side. Remember, whenever this base here matches this base here, everything it cancels out except for just the exponent. So what I can write is 3x minus 4. There we go. And now step 4 says isolate the x. So I'm going to go ahead and get x by itself. I'm going to add 4 to both sides. When you add 4 to both sides, you're left with 3x equals log base 12 of 0.1 and then plus 4. Please don't add the 0.1 and the 4. This log and this 0.1 go together. They stick together. You can't add something to them. And then next we're going to divide both sides by 3. So x equals log base 12 of 0.1 plus 4 all over 3. Now I want you to type that into your calculator. Let me help you do that. It's pretty tough to do. So let me help you do that, okay? But see if you have any questions here, kind of back it up if you need to. And I'm going to keep moving on. And here we are. Now I want you to type this into your calculator. You might have forgotten how to type in a base 12. Remember, your calculator only does base 10. So remember how to do this? If I taught you this about a week ago. If you have log base 12 of 0.1, remember what to do? You write log base 10 of 0.1 over log base 10 of 12. So if you'll type that into your calculator, this expression right here is the exact same thing as this over here. Now, I can't go back and reteach this. It is your job to know what I've taught you in the past. We have gone over this, okay? How do you type in a logarithm into your calculator that's not a base 10? Well, you do it like this here. So let me quickly type this in. You can type it in also and make sure you get the right answer. So log of 0.1 divided by log of 12. You should get out this decimal right here, negative 0.9266. So I'm going to come up here, and where the logarithm is, I'm going to put negative 0.9266, and then plus 4, and then all of that divided by 3. All right, so I'm going to go ahead and type that into my calculator, plus 4 divided by 3. If you type all of this into your calculator, you should get out this decimal right here, 1.0245. Now you might be off a little bit due to rounding, but that's basically the answer you should get. Okay, one more problem and we are done, and we'll get into our homework, so not too bad. Now this is a doozy, so bear with me. Matthew, Chase, you might have decided to work on your own. It's up to you. But if you do that, make sure you check and get this right, okay? All right. X equals 35. Now, are you ready, guys? Here we go. All right. Notice this is the type of exponential equation that has one exponent with one unknown, not two, okay? So we're going to use the steps to the left in your notes, to the left, and the first step is isolate the base and its exponent. Well, please watch my pen. I'm going to use red. Please watch this carefully. The 0.2 is not your base. Your base is 5, and your exponent is x. So that is what I want to isolate. Do you see that? The x is my exponent, the 5 is the base. That's what I want to get alone. So I must get rid of a 0.2. and I must get rid of a negative 16. So please follow along. Let me teach you how to do that. Since these are multiplying right here, the 0.2 times 5, we're going to save that for last. The first thing we're going to do is we're going to add 16 to both sides. So we add 16, that cancels those out, and we're going to add 16. So now we have 51 over here, and we have 0.2 parentheses 5 to the x. So now how do we get rid of the 0.2? Well, they're multiplying 0.2 times 5, so we divide by 0.2 and we divide by 0.2. So these cancel, and now you're left with 5 to the x power equals, let me type this into my calculator real quick, 51 divided by 0.2, and we get 255. 255. Are we okay with that? All right, so that was step 1. Isolate the base and the exponent. Step 2 says take the log of both sides. Now, I'm going to take the log of both sides. So log equals log. Now, what base do I use for my logarithm? Well, remember, you look at this number right here that's with the exponent. The last problem, it was a 12. This problem, it's a 5. So I put log base 5, log base 5. Then I bring this entire side down right here. So I have log base 5 of 5 to the x power. Then I bring this entire side down right here. And so I would have log base 5 of 255. Now, if you'll look at your steps, the next step says simplify both sides. Well, you really can't simplify this side over here, log base 5 of 255. But you can simplify this side. When the base of a log matches the base of the argument, everything cancels out and you're left with just the exponent. Okay? So this whole left side becomes x. And then step 4 says isolate the x. We already did it. The x is already by itself. So your final answer is, oh, you've got to type this in your calculator. Remember how to do that? It'll be log base 10 of 255 divided by log base 10 of 5. Okay? You should know how to do that. We've covered that quite a bit. So log of 255 divided by log of 5. And you should get 3.4429. Actually, you round the 9 up, so approximately 3.4430. Now you might get something different depending where you round it, but that's it. Okay? Now, that's it. Not a very long video. You should guys be fine with that. Now, here's the deal. Here's the deal. Here's your homework, okay? You have a choice to make. You have 9 problems to work on. I'm not going to collect this. I have really become a lot tougher on you guys when it comes to making you turning in your quizzes and tests on time. And if I change in the future, it will only be to get tougher, not easier. We cannot get off course. We must all stay together. But on homework, look, there has to be some give and take. You guys have got to learn to grow up and make good choices. So there's your homework. I'm not going to collect it. You need to do it. You know you need to do it. You need to make sure that you understand this math. All right? I am now going to work all of these problems out for you. So you have 2 choices. You can listen to the video and watch me work them out like we would do in class, or you can just stop the video, pause it, or turn it off, or come out of YouTube, whatever, and you can work these on your own, check them in the back of the book, and the ones that you missed, then watch the video for those. That's totally up to you, but I'm now going to go ahead and work these problems out for you, 25 through 41. So without any further ado, here's number 25. Number 25. All right, number 25 is this. It's 10 to the x minus 3 power equals 100 to the 4x minus 5 power. Now, you need to ask yourself, is this the type of exponential equation that has one exponent with one exponent with an unknown, or 2 exponents with an unknown? Well, obviously, we have 2 exponents with unknowns, so you want to use the steps to the right in your notes. And step 1 says write both sides with the same base. Well, if I want a 10 and a 100 to have the same base, I'm going to leave 10, but where the 100 is, we all know that 10 squared, think about it, 10 squared equals 100. So where the 100 is, I'm going to substitute 10 squared, and then I'm going to put 4x minus 5 there. Now let's go ahead and quickly simplify, and I guess I should have written that in as a step, but too late now. We're going to go ahead and multiply 2 times this whole expression here. So 2 times 4x and 2 times negative 2. We would have 8x minus 10. 8x minus 10. And now step 2 says cross off your like bases and set the exponents equal to each other. So x minus 3 equals 8x minus 10. Let's go ahead and subtract or move the 8x over and make it a negative 8x. So I'm left with negative 7x minus 3 equals a negative 10. Now we're going to bring this negative 3 over and make it a positive 3. So negative 7x equals a negative 7. Divide both sides by negative 7, and x equals 1. There we go. So that's number 25. Let's go on to number 27. All right, number 27 looks like this. 3, I'm going to go a little faster now. 3 to the x minus 7 power equals 27 to the 2x power. Okay, here we go. The first thing you ask yourself is this the equation where I have one exponent with an unknown or two exponents with an unknown? Well, we have two, so you use the steps to the right in your notes. Step 1, write both sides with the same base. So I leave my 3 of 3, but you should realize 27 is the same thing as 3 to the third power. Bring down your 2x. And now there's nothing we can do to the left side, but the right side, whenever you have a power raised to a power, right here, a 3 and a 2x, you multiply them. And step 2 says, cancel out your like bases and set your exponents equal. I'm going to go ahead and bring this x over and make it a negative x. So I'm left with negative 3 equals 5x. And now divide both sides by 5, and your answer is negative 3/5 equals x. Or if you want to put negative 0.6, that would be fine. All right. I'm checking the answers as we go to make sure I'm not making any little mistakes anywhere, so always give me a second to do that. All right. And they're getting negative 7/5. Let's see what I did wrong here real quick. Let's see. Okay, if you were following this problem, see this x minus 7 right here? I'm not sure why I made it a 3. And that's totally wrong, and I apologize. So we'll make that a 7, make that a 7, make that a 7. So we divide by negative 7. So the answer would be negative 7/5 equals x. I apologize about that. And let's move on. Number 29, for those that are following the video here. Number 29. Okay, the problem looks like this. 8 to the 5x power equals 16 to the 3x plus 4. 16 to the 3x plus 4. Now, when you look at that, you might think, oh, 8 squared equals 16. No, it doesn't. 8 squared equals 64. So we can't put 8 squared for 16. That's not what we're going to do. But what we might be able to do is write both of these with a 2. Now, if you think about that for a second, that really does make sense. For example, for 8, I can write 2 to the third power. That's 8. And then bring down your 5x. For the 16, I could write 2 to the fourth power. You've got to learn to think this way, okay, students? It's not easy, but it's what you have to do to solve these. So 2 to the third power is 8, so I substitute that for 8. 2 to the fourth power is 16, so I substitute that for 16. And now we go ahead and simplify. So 3 times 5x would be 15x. And then over here we have 4 times 3x and also 4 times 4. So we would have 2 to the 12x plus 16 power. Now, step 1 did say to write both sides with the same base, and we've done that. Step 2 says to then go ahead and cancel out your bases and set your exponents equal to each other. So 15x equals 12x plus 16. So now let's go ahead and solve. Let's bring the 12x over and make it a negative 12x, and that would leave me with 3x equals 16. Now let's divide both sides by 3, and you'll get 16 over 3 for your answer, or 5 1/3, or 5.3. Whichever answer you would like to use is up to you. Okay, let's move on to number 31. Number 31. Let's see what we got here. 31. Okay, now it's the new type, the other type of equation. Look at this one. Do we have two exponents with unknowns, or do we have one exponent with unknowns? Well, we have one. And so we're going to use the steps to the left in your notes. Step 1 says isolate the base and the exponent. Well, there's the base. There's the exponent. They're totally isolated, so step 1 is done. Step 2 says take the log of both sides. So here's the base of my exponent. It's a 2, so I take log base 2, log base 2. Then bring this whole side down, so I have 2 to the x power. Bring the whole side down, so I've got a 15 here. And now step 3 says simplify both sides. Well, I can't really simplify the right side, but over here on the left, whenever the base of your log matches the base of your argument, all of these are gone and you're left with just the exponent, okay? So this whole left side simplifies to x and you're done. Look at that. You're basically done. All you have to do now is type that into your calculator. So hopefully you remember how to do that. I'm going to grab my calculator real quick and type that in and we'll see what we get. It would be log of 15 divided by, don't forget to close your parentheses, log of 15, close your parentheses, divided by log of 2. And that'll give you let me check this in the back of the book to make sure we're right. Yep, 3.907. They decided to round to 3 decimals, 3.907. All right, well, let's move on to number 33. Number 33. All right, let's take a look at it here. All right, 4 to the x power minus 5 equals 3. Well, we have the type of equation that has one exponent with an unknown, so we use the steps to the left. Step 1 says isolate the base and its exponent, so we add 5 to both sides, and we're left with 4 to the x power equals 8. Good. I've isolated the base and the exponent. Step 2 says take the log of both sides, so I'm going to take the logarithm of both sides. What is my base right here? It's a 4, so I'm going to put a 4 here and a 4 here, and then bring down your whole side. So bring down the 4 to the x power, bring down your whole side over here, 8. Now, on the left side, whenever the base of a log matches the base of the argument, everything cancels out except just the exponent. So that left side becomes an x, and of course the right side is just log base 4 of 8. Now you've got to type that into your calculator, so it would be log of 8, don't forget to close your parentheses, divided by log of 4, and you'll get 1.5 for your answer. I'm going to check that in the back of the book, but I'm getting 1.5. That is correct. So your answer is 1.5, 1.5. All right, let's move on to number 35. Number 35. All right, let's take a look at this. Number 35. We have 10 to the 2x power plus 3 equals 8. All right, now we have one exponent with an unknown, so we use the steps to the left. Step 1 says isolate the base and the exponent, so we're going to subtract 3 from both sides. I'm not sure why I'm showing that. You guys know how to do this by now. So we subtract 3 from both sides. 10 to the 2x equals 5. Now the base and here's the base, here's the exponent, they're isolated. So step 2 says take the log of both sides. So we write a log here. We write a logarithm here. What is your base up here? A 10. So I put a 10 here and a 10 here. Bring down your whole complete side. So 10 to the 2x. Bring down your whole side over here. That's a 5. Whenever your base matches your base, everything cancels except the exponent, so the left side becomes 2x equals log base 10 of 5. Now the next step in your notes says isolate the x, so we divide both sides by 2. So we have log base 10 of 5 divided by 2. Now, if you type log base 10 of 5 into your notes, you should get this right here. 0.69897, and of course that's divided by 2 all over 2, and if you divide that by 2 you will get this. I'm going to kind of go up in a circle here. You will get 0.3495. And let me check that in the back of the book real quick and make sure that is correct. Number 35. Yes, that is correct. All right, let's move on to number 37. Number 37. And again, you can do a lot of these on your own, if not all of them. You don't have to listen to me do all of these if you don't need to. All right, number 37 is going to be a little tougher, so here we go. All right, 1/4, parentheses, 4, all of that to the 2x power, plus 1 equals 5. There we go. Okay, notice we have one exponent with an unknown, so we're going to use the steps to the left. Step 1 says isolate the base. Here's your base, and here's your exponent. Isolate them. So we have to get rid of a positive 1, and we've got to get rid of a 1/4. We have to get rid of them. So the first thing I'm going to do is subtract 1 from both sides. So I'm left with 1/4 times 4 to the 2x equals 4. I subtracted 1 from both sides. Now notice the 1/4 and the 4 are multiplying, so the only way to get rid of that 1/4 is to divide. So I divide both sides by 1/4. These cancel, and I'm left with 4 to the 2x power equals, and let's see, this should give you 16. 4 divided by 1/4 is 16. Use your calculator if you need to. And let's move on. Have we isolated the base and the exponent? Yes, we have. And so the next step we need to do, according to the left side of your note, says take the log of both sides. So log, and of course whatever this number is right here, that's the base I'm going to use. So log base 4, bring this whole side down, so 4 to the 2x, bring this whole side down, so 16. And of course when your base matches your base, everything cancels out except your exponent. So we're left with 2x equals log base 4 of 16. And now we're going to divide both sides by 2. So x equals log base 4 of 16 all over 2. Divide both sides by 2. And I'm not going to continue to go up on this page. I'm going to go ahead and cut and paste, and we'll continue this on the next page. Okay, now we need to type this into our calculator, the top part. So now you should have, let's see, log of 16, don't forget to close your parentheses, divided by log of 4 would give you a 2. So we have 2 over 2. So the answer to 37 is 1. The answer to 37 is 1. All right, let's continue on to 39 and then number 41, and we're done for the day, so not too bad. All right, number 39 looks like this. 10 to the negative 12x plus 6 equals 100. Now, I have the type of equation in which I have one exponent with an unknown. One exponent with an unknown, negative 12x. So I want to isolate the base and the exponent. That's step 1. So I'm going to subtract 6 from both sides. So 10 to the negative 12x equals, and then we're going to subtract 6 from both sides, and that would give me a 94. Now, I've isolated the base. I've isolated its exponent. So step 2 is take the log of both sides. So I take the logarithm of one side, the logarithm of the next side, and of course my base up here is a 10, so I put base 10, and I bring down my 10 to the negative 12x, and I bring down my 94. There we go. Now when your base matches your base like this, you're left with just the exponent, so negative 12x, and then over here I still just simply have log base 10 of 94. Now we're going to divide both sides by negative 12, so x equals log base 10 of 94 divided by negative 12. And let's quickly type that into our calculators. Okay, if you type log base 10 of 94 into your calculator, you should get 1.9731. All of that divided by negative 12, and I'm going to try to squeeze that down here somewhere, divided by negative 12, And let me look in the book here and check the answer. Yes, you will get negative 0.164. Okay, so there we go. All right, let's move on to number 41, and yay, I think that's it for the whole day. So we are done with the homework. All right, number 41, we have this right here. We have 3 to the 0.1x, 3 to the 0.1x minus 4 equals 5. Now notice right away this is the type of equation that has one exponent with an unknown, so we're going to use the steps to the left in your notes. Step 1 is to isolate the base and the exponent, so we're going to add 4 to both sides. So we're left with 3 to the 0.1x power equals 9. We added 4 to both sides. And then step 2 says take the logarithm of both sides. And of course your base here is a 3, so we put base 3. Bring this whole side down, so 3 to the 0.1x. Bring this whole side down, so a 9. Whenever a base matches a base, everything cancels out except the exponent. We've done that many times today, so 0.1x equals log base 3 of 9. The next step says isolate the x, so we divide both sides by 0.1. So log base 3 of 9 over 0.1. Now, if you type log base 3 of 9 into your calculator, and don't forget how to do that, of course, it would be log of 9, close the parentheses, divided by log of 3, close the parentheses. You should get 2 actually. So you get 2 over 0.1, and 2 divided by 0.1 is going to be 20. So the answer to 41, let me check the back of the book, the answer to 41 should be 20. And that is correct, okay? All right, so that's the homework problems you're responsible for, so hopefully you're doing well with those. And that is it for today.